Okay, hi everyone. My name is Sarwa Manggala Pravina. I'm from University Putra, Malaysia. The title of my presentation is Assessment of Microplastic in Commercially Harvested Aquaculture Products. It's an example from Malaysia because I think the plastic usage and the way aquaculture operates is very between countries. So as an introduction, global aquaculture production continues to grow faster than the major production and also expected to grow by 33%. And from these numbers, 92.5% of world aquaculture production has occurred in Asia Pacific region, and Malaysia is one of the top contributor. In Malaysia, aquaculture production can be divided into marine brackish and freshwater aquaculture type, and the major export products are actually freshwater fish, tilapia, catfish, shrimps, marine finfish, and many other more, as you can see in this slide. And then there are three types of aquaculture operation system. One is open, where the fishes were cultured in open sea or lake or river, and then there's a exchange between the water with the aquaculture production. While for semi-closed, although it's the aquaculture products are cultured in closed environment, but there is still water exchange in semi-closed aquaculture type. For closed one, the aquaculture products are in closed tanks, and most of the water source comes from tap water using RAS system. So here we can see, compared to the three types of aquaculture operation system, the closed one is actually more prone to microplastic pollution, because the particle that produce in this tank is difficult and entirely avoidable to escape away, because there's a very less chance of water exchange with waterways. And then in closed aquaculture system, there's a wide variety of plastic usage, where a number of plastic products were used in closed aquaculture system. Although there are findings reported on microplastic occurrence in aquaculture, but there are very less when we go narrow and search from closed aquaculture system. And some of the studies are available from China and also from few countries in Europe. So when we see from Southeast Asia region, is still limited, although this region is one of the most top contributor in terms of aquaculture products. So this study is actually to investigate the occurrence of microplastic in commercially harvested aquaculture species from closed aquaculture system, and to provide an insight of the characteristic of this particle and the possibility, the sources of this microplastic particle. So we took samples from farm A and farm B. Unfortunately, I can't reveal much about this farm information. And these are the species that we collected from farm A and farm B. And then all these species were cleaned, and then the scales are removed, and then we separated the muscle, liver, scale, and gastrointestinal tract, and we did the density separation method to extract the particle using sodium chloride hyposaline solution. Then it goes to the visual characterization, as well as processing the image using ImageJ to know the particle size, and also polymer identification using FTIR. We've also conducted several quality control and assurance to ensure there's no any external particle that can affect our data. So these are all the images of extracted particle from these 5 species from farm A and farm B. And when we look at closer, overall microplastic particle were detected in all the fish species from farm A and B. It is actually higher in farm A, Looking into the species, red Nile tilapia should be highest number particle detected, whether it's by number or weight. And then average abundance of microplastics actually more higher in gastrointestinal tract and lowest in liver. While for microplastic particle in farm A, the size is between 232.69 and 468.91 micrometer compared to microplastic particle size in farm B, which is a bit shorter compared to farm A. When we look at closely, we can see that the abrasive forces, the mechanical action, and it correlates well with the type of plastic products used in these farms, farm A and farm B. And these mechanical action were actually higher in farm A, which has led to higher number of microplastics. This is an example of plastic products used in farm A. If you notice, it's a blue color fishing net and red plastic pile with transparent plastic tubes. It's actually the main used plastic products in farm A. And in farm B, basically their plastic usage is actually transparent plastic tubes, another black plastic pipes were used in farm B. So when we compare the plastic shape, microplastic particle shape, it correlates very well. Fiber is actually highest in farm A, looking at the dominant usage of plastic nets in blue color, and in farm B, the most dominant are fragment, which we believe is actually from plastic pipes and tubes. In terms of color, actually it's matched very well with the type of plastic products they use. We can see the fish species from farm A, the color is dominated by red color. And if you notice, the red color is suspected comes from the fishing net, the lining of the fishing net, and the fragment color is actually from the plastic piles. We also feel that degradation of plastic net floating in these tanks is actually one of the possibility. The fiber was found as the highest in this microplastic particle from farm A. And the red color is actually from red plastic piles. For farm B, transparent microplastic particle is actually in fragment shape and comes from plastic tubes and pipe used in this farm B. In terms of FTIR, the findings showed that it matches well with the type of plastic product used, where HDPE is linked with plastic piles, nylon for fishing net, PVC for plastic tubes that used in these farms. So as a conclusion, microplastic particle were detected in all the fish species, which we believe is actually extended from the mechanical abrasion and defragmentation. The characteristic shape, color is actually linked well with plastic polymers data. Although this research or study has only showed the occurrence, but the actual risk of human health is still remain uncertain, which we think further study is needed to provide that understanding. So with that, thank you.
Thank you very much, Sarva. That was really interesting. I think we had John, I don't want to put you on the spot, but the panelists can't use the Q&A. But I think that one of the panelists may have had a question. So John, I'm just going to put you on the spot if you do have a question.
Sure, I do. You used a sodium chloride salt solution for your sample prep, but the density of polyvinyl chloride is greater than that density. So could you potentially be missing PVC in your analysis?
We do agree. There's a limitation in terms of the density separation solution, but in terms of other solutions available, we don't have other better solutions. So that's why we went for sodium chloride.
Gotcha. And is PVC widely used in aquaculture? Because I noticed that you had a lot of pipes there and stuff.
Yes.
PVC? Okay.
Yes.
Thank you.
Yes.
Thank you.
Okay, thank you.
Can give folks time to add their questions to the Q&A, but in the meantime, so, I mean, obviously having microplastics in aquaculture raised fish is problematic. So are there solutions to avoiding this? Are there other materials that folks can use, since you seem to be able to point to the equipment that's being used in harvesting these fish as, you know, are there solutions that you're proposing, or sort of what's the next step then of this research?
I have limited info on the next best solution to minimize this, but I think one of the main point is the aquaculture managers need to ensure they need to ensure the plastic products are not too old. You know, when you have old plastic products, the tendency it to break is higher compared to the new one. That's the one of the best way for now. Yeah.
And that's difficult, I imagine, because all these things
Exactly.
cost money, right? So
Exactly.
yeah,
Exactly. Yeah. Yeah. That's another challenge, because are they willing to do that? You know,
yeah,
they
and
are
is
profit minded. Yeah.
right. Is it a big enough problem for them
Yeah,
that it's
yeah.
worth the additional
Mm,
cost?
mm.
And maybe you answered this, or maybe you said this and I missed it, but so was this just a research study, or were you asked to investigate this?
This is
Not just a research, but
no,
you
it's
know,
a research study.
research question. Okay.
Yeah, yeah,
I didn't
yeah.
know if it was something that I mean, obviously you collaborated with the producers on this, but
And I keep their promise not to reveal about their farms.
I just muted myself. Any other questions for Sarva? Is there anything else? Yeah, John, go ahead.
So in aquaculture, disease and pathogens are a major concern, correct? So could potentially these things be absorbing to the microplastics and then finding their way into the environment? And they're thinking of them as a vector for biological materials. Is that possible? Is that something you're interested in?
Am I interested in studying the disease?
Yeah, could they potentially be a vector to spread disease, right? Because we know that you want to elaborate on that at all, or?
Yes, along with together with me, there's another researcher who did this investigation where he feels that the fish population has tendency to have a higher number of disease when we found higher microplastic in that tank. So I am not sure what kind of disease, but that's the statement made by my another co-researcher.
Thank you.
Mm-hmm.
That's interesting. It sort of opens up a whole suite of questions, right?
Yes.